Hello, I'm Neil, and in this video I'm talking about looking after servers, how we can deploy them, and monitoring those servers. Let's get into it. Once we've built the image that we discussed in the last video, then we need to deploy it. We need to update and deploy, probably on a regular cadence like weekly. Once it's deployed, we then need to keep an eye on it. Through monitoring and performance, we can create metrics and graphs. These graphs will provide us with data points so that we can improve the performance for our server and ultimately the performance of the end product to our customers. This playlist is based on a book which you can get from Amazon now. Our software development team will be deploying new software all the time, but we don't necessarily have to update the servers as often as we do deployments. Our software team will be doing deployments all the time of their new releases. We'll also be deploying the server. The two don't necessarily have to be deployed at the same time. Of course, if we're deploying a new server, then we'll be deploying the current version of the software that our server runs. We have a choice of how we can deploy our server and service. They are blue-green deployments, rolling deployments, and switch it off and on again deployments. Blue-green deployment is where we leave our existing services running exactly where they are, and we create some brand new ones, but they're not visible to our customers. Once the new ones are alive, we've tested this with our health checks, we then switch over the routing through either DNS or load balancer to the new services. Then we can destroy the old ones. This results in a very clean rollback because the rollback will occur before we've even switched the services over. Rolling deployment is slightly different. Let's say imagine a situation where you've got 8 servers running your product. In a rolling deployment, one of those servers will be destroyed, now we're running on 7, and a new one will be created in its place running the new software, back up to 8. We can then rinse and repeat this process until all of them have been replaced. The final method, probably not going to go with this one because it results in downtime, but is very popular in monolith systems. This is where you down the original system, update it, and then turn it back on again. So in summary, we've got blue-green, which is the default for Amazon's ECS services, rolling, which is the default for Amazon scaling groups when you do an instance refresh, and on and off, which has been the default for monolith systems for many years. Once our server and service is deployed to production, or even before that, say performance environment, we can register various metrics about how it's performing. There are 2 schools of thoughts on this. The acronym USE, USE, and the acronym RED, RED. In USE, we measure the utilization. How much of the resources is being consumed right now? This might be the amount of memory or the amount of CPU, if it's 50% or 60%. Saturation is where we run out of resources. How many queues, events and things are as a result of not having enough resources. This might be a processing queue if you've got a background processing service, or it might be a CPU queue if you're looking at individual CPU metrics. And then there's errors. This is how many errors are occurring as a result of the performance of the box. You might not see any errors if your application is particularly fault tolerant, but if you do, then this will show us the action we can take. Red focuses more on the application metrics. Rate, the amount of requests that the application is processing. Errors, the number of errors that we're receiving as a result of processing. And duration, the length of time it takes to process each request. Using red will give you a baseline so you can understand when the system is being overloaded. It's useful to have a performance environment so you can measure what idle and busy looks like from a rate perspective. With these metrics getting collected, we need to get some useful information out of them. To do this, we have alerts and dashboards. Alerts will be fired when preset thresholds are breached, thus telling the team when something needs to be looked at. And the dashboard is useful so that we can see the historic data that led up to that alert. Talking of historical data, we then have logging. Logging helps us understand what the application is doing, and when it goes wrong, if we can resolve what went wrong by looking at the logs and the output. We can also create metrics from logs. By counting the number of errors in the logs, this enables us to have an error metric. When looking for specific errors, like those that we would see from an alert, it's useful to be able to search the logs as well. When deploying, and indeed at runtime, things can and will go wrong. We need to be able to have a system in place where we can handle these errors. These failures may start right at the outset. We've deployed the server, it's gone wrong, there's no health check, it's not going right, and we have to roll back. A rollback is a sensible outcome of an erroneous deployment. If we're using a blue-green deployment, then the customers won't even notice it's happened. We can then analyze the logs that we've captured to work out why it went wrong. There will be times when the application or the server just crashes. There's a bug in the application which causes a memory overflow, then that can cause the process to exit, running out of memory. And if we're on a cloud provider, then we're not in control of the underlying hardware that sits underneath our application. That hardware could go wrong, in which case we need to handle the error at that point as well. By deploying multiple copies of the servers and the applications is one way of defeating the errors of the hardware. When the system detects that a hardware has failed, or a server has failed, or an application has failed, we can have processes in place that will kill that, replace it with a brand new one. When replacing it with a new one, it's important to have the same config as the rest of the cluster. If you've got a good enough automation system that when a thing fails and it dies it gets replaced, then we've got a self-healing. The only other thing to mention here is data. If we've got servers failing, then all the data it holds goes with it, so we need to be able to keep that safe. We can make regular backups, in which case when something fails we can go back to a point in time to restore. The more robust way is replication. This is where we've got a number of nodes in our cluster and we're copying the data multiple times amongst that cluster. Elastic uses this method, shard the data, and copy it in more than one place on the cluster of nodes. Then there's the ultimate in disaster recovery, off-site backup. This is in case something goes really wrong, like a data center catching on fire, which can happen. We need to make sure that that data is not in the same site, out of the physical harm that could happen to that data center. This is why Amazon provide availability zones. That is 3 data centers or more within close proximity to each other, but not close enough to be able to catch fire to each other. If you've got applications running across regional zones as well, then that will help your customers get a faster response. Till next time.